Hi everyone, welcome to lesson 25. This is the first lesson in our second unit. So unit 2 will include lesson 25 all the way through lesson 31. Most of these lessons will be about different kinds of factoring. So in this first lesson, we will really focus on actually two types. So there will be a part 1 as well as a part 2 of lesson 25. The first type will involve factoring out a GCF, which stands for greatest common factor. And then our part 2 of this lesson will expand beyond that and deal with factoring by grouping. All right, so let's get started. Our first little definition here, if A times B equals C, then A and B are factors of C. You've heard the word factor before. We've reduced fractions by finding common factors in the numerator and denominator. So we're going to be doing something that may feel like reducing a fraction, but instead of reducing a fraction, instead of looking at a numerator and denominator, we're looking at different terms of a polynomial, and we're trying to find what they have in common. What are they both a multiple of? All right, so I'll kind of walk you through the steps here of finding a GCF, or a greatest common factor, and we'll take it from there. Okay, sorry, here we go. So how to find the GCF of polynomial expressions. Step 1, write each term as a product of prime factors. I will just tell you, I'll do this sometimes. A lot of times I will not. Just like now we should be at the level where when we reduce a fraction, we don't necessarily break each number down using an elaborate factor tree every time. You might be able to kind of do it in your head or have an abbreviated way of showing that process. All right, and then our next step, step 2, find the prime factors they have in common. And if there's more than one of those things they have in common, you're going to multiply the common factors found in step 2. As always, I find that seeing steps written out is less helpful than seeing an actual math example. So let's just move into our examples here. Please notice the instructions say, find the greatest positive common factor. We will eventually move to problems that just say factor, which will be different. That word factor can be a complete sentence. Right now, we are just finding the GCF. We're finding the greatest positive common factor. So let's take a look at what that means. Here's our first example, 6x plus 14y. So I will be a little bit more detailed in my showing work for this first problem, and then maybe a little bit less so as we move on. Okay, so 6x plus 14y. Write each term as a product of prime factors. So x is its own factor. We don't know what x is, but what we can break down is 6, and we can break that down into 2 times 3. So this first term can be written as 2 times 3 times x. Now the second term, 14y. So y is just its own factor. And then if we break down 14 using multiplication, that would be 2 times 7. So if we look at these terms broken down, 2 times 3 times x, 2 times 7 times y, the thing that's the same, of course, is the 2. That is the greatest positive common factor. So our answer for this problem is 2. That is called the GCF. Now, very soon we'll have to do more than just find the GCF. We'll have to actually do something with it. But right now, when we're finding the GCF, there it is, we found it. The answer is 2. There's nothing else in common in either of these lists of prime factors. This is the only thing that's the same between those two terms. All right, I'm going to move over here to example B, 5x to the third plus 31x to the 7th minus 7x squared. Now, this one is going to be a different type of problem. 5, 31, and 7 are all prime already. So those are already prime numbers. So let's just notice that. So there is no prime factor that is common between these two because 5 does not go into 31, 7 does not go into 31, 5 does not go into 7. They have no shared common factors. However, we need to pay attention to the variables. Okay, so x to the third, x to the seventh, x squared. They all have x's. Now, it's going to look a little bit strange, but if I were to break this down using a factor tree, it would be a little bit messy, but here's what it would look like. I'd have 3 factors of x, 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 x. Then, so that's kind of my one-step factor tree with 3 little branches here, x times x times x. Same thing with the x to the seventh, only now there's 7 of them. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. I don't do this every time. So you can see already how kind of tedious this is. All right, and then for the last term, that's just x times x. So what do they have in common? What do these 3 strange factor trees have in common? What do they have that's shared? They all have x's. So let's highlight what they have in common one at a time. So here's a common factor of x, 1, 2, and 3, like that. So they all share a common factor of x. Oh, wait, but they also share a second common factor of x. See how this factor tree is out of x's? There's nothing else that could be shared with all 3 terms. That is a very long way of saying our GCF is x squared. So if you need a shorter and less elaborate way of figuring that out, we're going to take the smallest exponent of any common variable. So if you notice your terms having the same variable, same letter in each term, pay attention to the exponents. The GCF, the greatest common factor, will just be the one with the smallest exponent. So once again, we have found the greatest positive common factor, which was x to the second power, or x squared. Technically, the coefficient, the number in front here, is just a 1, because in terms of 5, 31, and 7, the GCF between those 3 numbers is just 1. Now I'm going to erase this 1 now, because I don't really want you to write it in your final answer, but I want you also to know that it's there. All right, third example on here, this is letter C now. 14a to the third plus 22a to the seventh plus 2a to the fourth. Let's start with the numbers first. So between 14, 22, and 2, rather than making a factor tree for each one, which you could absolutely do, I would suggest starting with the smallest number and see if that goes into the others. So if it does, that's your GCF. So 2 does go into 22. 2 is a factor of 22, and 2 is a factor of 14. So our GCF will have 2 as part of our answer. And I'm saying part of our answer because we also now need to focus on our variables. Each term has the same variables. They all have a. Just like in the last problem, we do need to once again pay attention to the smallest exponent. So between these 3 terms, the smallest exponent is this 3, this a to the third. So we put that, we multiply it right here with the 2. We're just writing it next to the 2. It doesn't really feel like multiplication, but that's what it is. So our greatest common factor is not just 2, but it's 2a to the third. Okay, and if we had made little factor trees, we could do that pretty easily. 14 would be 2 times 7. 22 would be 2 times 11. 2 is just 2. The common factor there is 2. Okay, so you can kind of see it that way as well. So each of these problems involved finding the greatest positive common factor. We looked at the terms, we broke them down, either by writing things out or in our head, and then we found what the terms had in common. It might be a number like 2, it might be a variable like x or a, and if it's a variable, we're going to take the smallest exponent for that variable to find the GCF. Now, where all of this is going is for the most part, we're going to not only need to find the GCF, but also factor it out. So that's going to lead us to our next set of problems here. So now, not only are we going to find the GCF, but we are going to factor out the GCF. Okay, so we have 4 problems in this set here. So factors. So to do this, what we're going to do is find the GCF, but then essentially divide each term by the GCF. It's sort of like the reverse of the distributive property. So I'm going to write that here for us. It's the reverse or opposite of the distributive property. Okay. And as you should remember, in our previous lesson before our test, lesson 24, we talked about dividing. We talked about dividing by monomials. That's essentially what we're going to be doing here. So let's do number 1. First, we're going to find the GCF between each of these terms. 6a squared plus 2a. I'll put a little 1 here, just to remind you there's an exponent of 1. Our GCF, let's do the numbers first. Between 6 and 2, the GCF would be 2. And the GCF, or greatest common factor, between a squared or a to the 1, the smallest exponent is that a to the 1. So that is our GCF. So what we're going to do is take our original terms and divide them by the GCF. So we'll divide each term by 2a. And here's what's going to happen. When we divide by the GCF, essentially what we're doing is we're factoring it out. This is the opposite or reverse of the distributive property that I was talking about. So it doesn't go away, it comes to the outside of parentheses. So instead of distributing or multiplying, we're dividing instead. So I'm dividing each term by 2a. The 2a comes out to the outside of the parentheses. The original problem started with 2 terms. My final answer should also have 2 terms. So let's remember how to divide here. 6a squared divided by 2a. I'm going to do 6 divided by 2, that's 3. A squared divided by a, remember there's a 1 there. Subtract the exponents, 2 minus 1, that's going to be a to the 1 or just a. So my first term now is 3a plus. Be careful here, 2a divided by 2a, that's just going to be 1. Sometimes people think it's 0 or something else. So be careful, it's just 1. This right here is my answer. This is mostly what we're going to be doing in this lesson. And you'll continue to do it throughout this whole unit when we talk about different kinds of factoring. Factoring out a GCF is going to be something that comes up a lot. So we're going to get used to it now, and we'll keep getting better at it. One way you can check your answer is by distributing. So maybe in your head or off to the side on your paper, you can distribute this 2a, see what happens. 2a times 3a, that's 6a squared, plus 2a times 1, that's 2a, right? So when you distribute, you should get back to the original problem, right? Okay, so that was number 1. Let's do another one. Here's number 2. 3rb minus 6rc plus 12rd. So let's look at our numbers first. 3, 6, and 12. Let's find the GCF between those 3. The smallest number is 3. 3 is a factor of 6, and 3 is a factor of 12. So we should be safe saying that 3 is part of our GCF. And I'm going to show my work slightly differently here. I'm going to set this up, so I'll just start dividing by my GCF. Okay, what else do you see that they have in common? Well, there's a letter or variable that is the same, or that is showing up in each of these terms, and that's this letter R. So our GCF is 3R. So we're going to factor out the 3R. This will become part of our final answer. So there's our GCF on the outside of the parentheses. And when we divide each term by 3R, notice that there's 3 terms in the original problem. I should now have 3 terms left over in my final answer. So 3RB divided by 3R, those essentially cancel. I'm left with just B minus 6RC divided by 3R. 6 divided by 3 is 2. The R's cancel out, and then we still have that letter C. Plus 12RD divided by 3R. 12 divided by 3 is 4. The R's cancel, and then you're left with that D. So my final answer is 3R, parentheses, B minus 2C plus 4D. Once again, you can check by distributing. Okay, so you could distribute that 3R to each of these three terms, and you should end up getting the same thing that we had started with. Okay, so that's the main idea. We're going to keep going with some just slightly trickier examples, but it's the same concept every time. Okay, moving on to number 3, y to the 4th plus 3y to the 3rd. Okay, this y to the 4th doesn't appear to have a coefficient, which means it's really just a 1. So the GCF between the coefficients, 1 and 3, is just 1. Okay, so technically we're dividing each term by something with the 1, which would mean we're not changing it at all, right? Okay, so what's really in common here has nothing to do with the coefficient numbers. It has to do with the variables. So they both have y. We'll take the smallest exponent, which is y to the 3rd. We're going to divide each term by 1y to the 3rd. So the GCF is actually just y to the 3rd here. So we'll put that on the outside of our parentheses. In this problem, we started with 2 terms, so we'll end with 2 terms in our parentheses. 1 divided by 1 is 1. Y to the 4th divided by y to the 3rd would be y to the 1, or just y. Remember, we're subtracting exponents when we do that. Plus 3 divided by 1 is still 3. Y to the 3rd divided by y to the 3rd, that would actually be y to the 0, which would just be 1. So actually, I don't even want to write any y here at all. If I were to write y, that would be wrong. If I were to write y to the 0, that would just really technically not be simplified. So this is my final answer here. Y to the 3rd on the outside, parentheses, and then y plus 3. And once again, you can check by distributing. Y to the 3rd times y is y to the 4th, plus y to the 3rd times 3 is 3y to the 3rd. So again, this distributing that I'm kind of half showing you at the end, that is a way to check your answer. Okay, one more of these in this little set here. This one, it just looks harder with all those variables and looks like a big mashup of numbers, but it's still the same idea, okay? So let's take it one step at a time. 16 and 24, let's start with those. Now 16 does not go into 24, so we really do have to break these down. We're looking for common factors between 16 and 24. You might think 2 or 4, but actually the greatest common factor is 8. I think I will show this one in a little more detail. If I were to factor, let's say I started by dividing by 2, 2 times 8, that's prime. 8 would be 2 times 4. I'm circling the 2 because that's prime. 4 would be 2 times 2. So look at all these factors of 2, right? And then if I break down the 24, that would be 2 times 12. 12 can be 2 times 6. 6 can be 2 times 3. So check out what they have in common. If you do it this way, the common factors, they have a 2 in common, and another 2 in common, and another 2 in common. If I just focus on the prime numbers. If I multiply those together, 2 times 2 times 2, that's a roundabout way of getting 8 as my GCF. Oops. Okay, it's possible that you came up with that answer without making a factor tree, which is great. But the factor tree option is there if you need it. 2 times 2 times 2 is 8. Now we'll focus on the variables. Let's look at the a next. A to the 3rd, a squared. Whichever one is smallest, that's what we're going to be bringing out to the side here. So that would be the 2 exponent. Same idea with the b variables, b squared or b to the 5th. Let's bring out the b squared again because that has the smaller exponent. And finally, with the c to the 7th versus the c to the 5th, the smaller exponent is c to the 5th. Okay. Now I'm a little short on space here, so I'm going to do a bit of erasing so I can show my work for dividing. So feel free to pause and make sure you got everything copied down here. Okay. What I'm going to do now that we've come up with our GCF, 8a squared b squared c to the 5th, we're going to divide each of our original terms by the GCF. And whatever we get when we divide is what will go in the parentheses. So 8a squared b squared c to the 5th, 8a squared b squared c to the 5th. And something important to notice here is when we're factoring out the GCF, when we're factoring out the greatest common factor, when we're done with the problem, the terms left in the parentheses should no longer have anything in common. And you can look back at our previous examples. For example, number 1, 3a plus 1, no common factor there. Nothing in common there between those two terms. b minus 2c plus 4d, nothing in common with all three terms. You might notice the 2 and the 4 having a common factor of 2, but the first one doesn't. And then once again in number 3, the y and the 3 have nothing in common. So just keep that in mind. Let's carefully divide. Again, we found the GCF, 8a squared b squared c to the 5th. And now we're going to divide each of our terms by that GCF. Okay, 16 divided by 8, that's 2. A to the 3rd divided by a squared. If I subtract those exponents, that's just a to the 1, or just a. B squared divided by b squared, that's just a whole number 1, okay? That's why I get to just cancel that out. It's like I'm multiplying by 1 right now. And then finally, c to the 7th divided by c to the 5th, that's c squared. Because once again, I'm subtracting exponents. Okay, that's my first term, plus. Now, my second term over here, 24 divided by 8, that's 3. A squared divided by a squared cancels out to just 1, so I don't need to write anything there. B to the 5th divided by b squared, I'm subtracting the exponents. 5 minus 2 is 3, so that's b to the 3rd. And finally, c to the 5th divided by itself is another 1. So it's like I'm multiplying everything by 1. All right, so check out what's in our parentheses. 2ac squared plus 3b to the 3rd. There's no common factor between those terms other than 1. Okay, 2 and 3 have no common factor. This first term has a and c, the second term has b. They have no shared variables. So our final answer is right here. Okay, so 8a squared b squared c to the 5th, that big thing is the GCF on the outside of the problem, parentheses. And then the inside of the parentheses is what we got when we divided each term by the GCF. All right, good. Let's see what we have next. Oh, and then here's that note I've been saying, to check, multiply the factors using the distributive property. Yep, we saw that. Okay, now what we've been focusing on so far here, let's see. Okay, excuse me while I peek ahead. I'll come back to that slide, hang on. Da, da, da. Okay, there we go. I just wanted to see how close we were to part 2. All right, not quite there yet. What we've been focusing on so far is positive GCFs. We've been looking at greatest positive common factor. What we're going to see in these 3 problems is these are polynomials where the leading coefficient, the first term, is negative. So what that means is we can factor out a negative. So we're going to factor out a factor, I should say a common factor, GCF, with a negative coefficient. So we will do this whenever our leading term or leading coefficient is negative. Otherwise, it's pretty much the same process as what we were doing before. because we're going to be factoring out a negative, we'll have to keep track of signs a little bit more carefully. So number one, negative 3a minus 6. The common factor here is 3, okay? 3 goes into 6. But actually, it's not just 3, it's negative 3. So I'm going to divide each term by negative 3. Negative 3 is my GCF on the outside. Pay attention when we're dividing by a negative, we're going to change the signs. Negative divided by negative, this is now positive. 3 divided by 3 is 1, and I can just leave the a. So you can write 1a or just a. I had a minus sign next, which means I'm about to have a plus sign here. Negative 6 divided by negative 3 is now positive 2. Okay, and just like before, we can check by distributing. Okay, so imagine you're distributing that negative 3. Negative 3 times a is negative 3a. Negative 3 times 2, that would be negative 6, right? See how it checks out, and it's still the same as the original problem. All right, good. Number 2, negative b to the 4th minus 5b squared plus 20. We have 3 terms here. Now at first it looks like I'm going to be factoring out some power of b, and maybe it looks like I'm going to factor out a 5 because there's a 5 and there's a 20 and 5 goes into 20. But if you look carefully, actually, it doesn't seem like there's really any common factor in this problem at all. Okay, this last term doesn't have any b variable at all. This first one doesn't really have a number in front of it other than just negative 1. So all we can really factor out is negative 1. Anything else you try, you're going to get stuck and not be able to simplify as you're trying to factor out something that you think might be in common. Okay, so I'm factoring out a negative 1. Might seem a little strange. All we're going to do is pretty much copy the original terms, but just change the signs as we do that. Negative b to the 4th divided by negative 1 is just positive b to the 4th. And technically there's a 1 there. Negative 5b squared divided by negative 1 is now positive or plus 5b squared. Positive 20 divided by negative 1 is now negative 20. And that is my final answer. So once again, I've factored out a factor that has a negative coefficient. In this case, it's negative 1. All right, number 3, negative 2x to the 5th plus 8x to the 4th minus 2x. So let's take a look here. I see a 2. A lot of times we factor out 2's. And that's the case here. Each one of these coefficients, 2, 8, and 2, they can all be factored out, they can all be divided by 2. And I know it's going to be negative 2. Now what about the x's? Let's see, if I look at each power of x, I want to take the smallest exponent, and each term does have an x. This last term, remember that exponent is really a 1, so that's going to be my GCF right here, 2x to the 1, or just 2x. And actually it's negative 2x, because our directions did say to factor out something with a negative coefficient, and now we know to do that anytime our first term is negative. Okay. Good, so our GCF is negative 2x. And let's see what our 3 terms are in the parentheses. Negative divided by negative, positive. 2 divided by 2 would be positive 1. I'm not going to write that though, because I know I have some x's to write. And this is my attempt at showing you that's a 1 exponent. 5 minus 1 is 4. So this will be just 1x to the 4th, or just x to the 4th. 8 divided by negative 2 is negative 4. Subtract these exponents. 4 minus 1 is 3. And then finally, my last term here, negative divided by negative is positive. 2x divided by 2x. This time I do need to write a 1 because the x's actually just cancel out entirely. This would technically be x to the 0. Okay, so it's 1x to the 0, which is 1 times 1. I should just write 1 for my final answer. So here's my final answer. So negative 2x, parentheses, x to the 4th minus 4x to the 3rd plus 1. All right, good. So that was kind of more of the same idea as the earlier problems. It's just that each of these started off with a term that was negative, and we were factoring out a negative as part of our GCF. Okay, one last little set here in this part 1 before we take a little break, and then we'll do part 2. When we get to part 2 of this lesson, we're going to be doing something called factoring by grouping. And so these two problems are kind of meant to prepare us for what we're about to see. We're going to see a lot more with parentheses, and the problems will just be a little bit longer. So let's look at these knowing what we know about GCF. Okay, so we can actually factor out a binomial GCF. What are we talking about? Okay, so bi means 2, right? So we're looking at a common factor that actually has 2 terms in it. So a binomial GCF. So if I look at this first problem, r parentheses y minus 3 plus z parentheses y minus 3. It's the y minus 3 that's the common thing. That's the GCF. That's what we can factor out. Now, before we fully do that, I'm going to do a similar example over here for you. So similar example. Oops, I don't want that to be yellow, sorry. Similar example. Let's say I had RP plus ZP. I'm just saying P for parentheses. In this problem, RP plus ZP, wouldn't you take out the common factor of P? Then you'd be left with R plus Z. That's essentially what we're trying to do over here, only instead of P, it's a thing in parentheses. Okay, so that's really what we're going to be doing. And instead of just, again, instead of P, it's something in parentheses. So instead of one single variable, it's an expression. So our final answer, starting now, a lot of times our final answers will have not just one set of parentheses, but actually 2 sets of parentheses, because one of them is the GCF. Okay, so back to number 1. R parentheses y minus 3 plus z parentheses y minus 3. The greatest common factor is y minus 3. And I do need to leave it in parentheses because it's a binomial with 2 terms. Now what's left over? Well, look at our similar example. Remember how we had r plus z left over? R plus z is left over. So this is now my final answer. Okay, so that's different. We kind of just leveled up from the problems we were doing before. Number 2 is similar. See if you can tell this time what's the GCF. A plus 2, a minus 5, plus a plus 2, a plus 4. Think of this plus sign as kind of separating the problem into 2 different, really big expressions here. What are the parentheses that kind of match, that are the same? This time it's the a plus 2. So when we write our final answer, or maybe not our final answer, when we take out our GCF, it is going to be a plus 2. Now this time, what's left over? Well, I have a minus 5 plus a plus 4. Okay, so this is now a little bit more complicated because it's not just r plus z. It's not just one thing plus another thing. It's a thing in parentheses plus another thing in parentheses. Okay, I'm gonna add just a little, I know I'm changing my colors all over the place here, but I think it can help, so let me attempt to do that. I'm just doing a little bit of highlighting here, just so we can try to follow what's going on. Okay, so for number 2, here's where we are so far, and we're not done, by the way. We notice our GCF, our greatest common factor, was actually a plus 2. That's a binomial, 2 terms. So I factored it out. I factored out a plus 2. That part's kind of done, okay? We're done with the a plus 2. Now, we have this other leftover stuff in what appears to be many different layers of parentheses. It's really one big expression here. So what we had left over is a minus 5 plus a plus 4. What we now need to do is just combine like terms and put those things together. So let's do that. So a minus 5 plus a plus 4. We essentially need to combine like terms or collect like terms, which isn't something you've heard in this lesson, but you've done it. All right, so the a's are alike, so we'll combine the a's. A plus a is 2a. And then negative 5 plus 4 is negative 1. So 2a minus 1. And then I'll just bring down the a plus 2. And that is my final answer. Now, please notice that our final answers right now are kind of looking like the beginning of FOIL problems, right? Remember FOIL? I just did that recently. We were used to problems starting like this and then we were distributing. Now with factoring, we're doing the opposite of distributing. So we're ending up with answers in parentheses. So that's taking some getting used to probably. Okay, so this is about the halfway point in lesson 25. Probably during class in a regular class time, I would have us take a break at this point, and then we'd come back and continue the lesson. So I will end the video here. This is part 1. Give yourself a little break and then come right on back and continue with lesson 25, part 2. All right, see you soon.